Turn on the recorder. And we've got this is kind of the example I want to start with. So f of x is equal to x plus 3 over -1, x minus 7, x plus 10. Oh, you know what? Well, yeah, so I wanted to, that's actually not the original problem, sorry. But I wanted to give you both versions. So, and I think this is how it appears on the exam as well. You have the factored form and you have the non-factored form. I wrote down the wrong one first, but this is the same function, so these are both fx. So once it comes to actually graphing, I think there's enough going on. I don't want to make you factor again as well. So I'll give you the factored form on the exam. But anyway, so how do you graph this? Well, first we need all that information that we just covered in the quiz, which is x-intercepts, the y-intercept, the VA, vertical asymptotes, the horizontal asymptote, the slant asymptote, and as well as any holes. I always forget about the holes. It's probably not, the most important thing in the world, but should have the holes there as well. This one doesn't have any holes, so. So we have to find all this information, right? And since I gave you the factored form, a lot of this stuff is pretty quick. So for example, we've got the x-intercepts. Well, that's just the factors on top. But since I'm kind of caring about the graphing, oh, you know what? I didn't think about that. Maybe I should have talked about multiplicities ahead of time, but that's okay. We'll do that maybe in a different example. Yeah, I've got a good example next too, where the multiplicity, well, yeah, I got another example later where we're really getting to the multiplicities, but we actually do care about the multiplicities here. Now, the multiplicities here are all ones. So this is going to be a cross. Okay, so that's the x-intercept. The y-intercept is just you plug in 0, so you're going to get 3 over 70, which is kind of a weird number, but it works. Very small, almost 0. For VAs, those are the factors on bottom. So we get x equals 7 and x equals -10. And again, as I just alluded to, I was kind of debating in my head. Sorry, I was talking out loud there. I don't know if it made a whole lot of sense, but we are going to care about these multiplicities of the vertical asymptotes as well. So these are both crosses as well. And finally, the horizontal asymptote or slant asymptote, well, that comes from a long division. But, as you can probably tell without even setting it up, maybe I will actually set it up, but I think you can kind of figure this out without even setting up the long division. X squared doesn't go into X. Or if it does go in, it goes in 0 times, right? So that's your horizontal asymptote, y equals 0. We haven't done an example like that, but that's how that works out. And there might have been one of those on the homework, I don't remember. But if the degree on the bottom is bigger than the degree on top of the leading the leading term, then your horizontal asymptote is going to be 0. And that makes sense. So as x gets really big, this is going to be much, much bigger than this. So essentially, you're just going to get 0 for very, very big x or very negative x as well. Okay, so that's all the information we need to graph it. Let me go ahead and let's do a new page here. So let me set up some big axes here. So what do we have? It goes up to 3. Look here. Yeah, -10, 7. So we've got -10 way over here. We've got -3 here. We've got 7 over here. Now the y-intercept is very tiny, but I'm going to put it there maybe. And so let's put in all this information. So I already got the numbers here. The -10, that was a vertical asymptote. So I'm going to draw a dotted line there. 7, also a vertical asymptote. Draw a dotted line there. The 3 was a root, so I'm going to do a dot there. I know it goes through that point. 3/7, that was the intercept. I know it goes through that point. So it's 3 over 70. And the one other thing we had was that horizontal asymptote at 0. So I'm going to draw that in as just a dotted line at 0. Here's what I would recommend. Well, okay. So let's start actually at the horizontal asymptote. So I know it's going to follow this horizontal. Actually, let me get a different color. So here I'm actually graphing the function now. This function is going to follow this horizontal asymptote on both ends. I know that's kind of where it is on both ends. It's really going to follow closely. Now, unfortunately with this one, and this happens sometimes, you don't really know where to go from here. You know you cannot cross a VA. So we know we're not going to just cross through this VA. So we're either going to kind of go this way, or we're going to go this way. But it's actually kind of impossible to know based off of the information we have so far. So let me erase those. And instead, let's go maybe to these intercepts. So this intercept and this intercept. So we know the function goes through these two things. So, I mean, it seems like it has to just kind of travel this way. And then it has to cross through. This was a cross, remember? But it has to cross through here. And now this gives us a direction of where the function's going. As we move to the left now, again, it's going to kind of avoid this asymptote, but it has to go down to do that. So it's going to follow the asymptote in a downward direction. This allows us to actually know what's going on over here as well, though. So we're following the asymptote this way, but this asymptote was a cross. Now, I haven't told you what that means yet. So actually, let me start a new slide. Also tell, this is just going to be real quick, VA multiplicity. So if it's something like x minus 3, say 1 over x minus 3 cubed, so some odd number here. If this is odd, then your vertical asymptote is going to look something like this. it's going to be going up on one end and down on the other. And I call this a cross because I think of it as actually crossing over the whole graph. It's like crossing through infinity somehow. It crosses over this way. It basically crosses over the whole graph through infinity, crosses through infinity. Now, if this were an even, so if this was like x minus 3 to the fourth, if this was an even number, then it's what I call a bounce, just like an x-intercept would bounce, but it looks different. Here's x equals 3. Now it's going to follow the asymptote, and I think of this as bouncing off infinity, so it's going to go kind of the same direction. So this is a cross, this is a bounce. Anyway, after that little digression, back to our function. So where we were kind of following it over here. We're following down this asymptote. We know this is a cross, so it's going to cross over the whole graph and must be coming up like this. So and then it's going to follow the asymptote. So it'll look something like this. And the idea with these graphs is not that they're perfect, but you're just trying to get a sketch that captures the key information. Okay. Going over here, let's continue right here. So our graph, continue along, we're hitting another vertical asymptote. So we know we have to veer either up or down. But if we veer down, we would cross over the x-axis. But there's no intercept there. We've found all the intercepts. The only intercept is -3. So we have really no choice but to go up here. And this is another cross vertical asymptote. So if we're going up on this side, we cross over the whole graph, and we come down on this side and continue on our horizontal asymptote. So there you go. This is a picture of the function. I would definitely recommend, you can do this on the, exam. I would definitely recommend checking your answer with Desmos. So let's go ahead and plug this into Desmos and see what it looks like. I'm going to type in x plus 3 divided by -x squared minus 3x plus 7. Okay. So yeah, I think we did a pretty darn good job of capturing the key pieces of this graph. Now mine is a little bit curvier than the one on Desmos. Desmos is more accurate, but what I actually like better about mine, even though it's less accurate, I think it tells you the key features better. So I kind of like graphing by hand. And again, I really want you to graph by hand because you have a much, much better understanding what's going on than if you just keep typing it into Desmos. Okay, I'm going to stop the video there.